this lesson, we're going to emphasize even further. Yesterday we were working with proportions, and we saw that you can solve proportions using equivalent ratios, and we saw that you can solve them with that cross-multiplying algebraic method, and we also focused on setting up and solving a proportion. Our work today is virtually identical to what we were doing before. Because proportions are such a massively important concept, we don't want to just rush through them in one day, so we have a second day, a second homework for them. But there is one other objective that we're adding to it. In particular, we're going to also use cross-multiplying to figure out if two ratios are actually proportional. We will also use cross-multiplying to solve, and then we'll also see setting up some word problems like we had done yesterday. So, just asking the question right off the bat, are these ratios proportional? You can also phrase these directions are, do they form a proportion? Or you can say, are they in proportion? They're all ways of saying the same thing, but essentially, we're just asking, hey, come on, come here. Are they equal? Because that's what a proportion is. A proportion is a statement that they are equal, so we're simply asking the question, are these equal, yes or no?
I know this. I remember this.
Cross-multiplying will give us the answer almost immediately. Just multiply 9 times 34. Okay, so that's 270 plus 36. 270 plus 36 gives us 306. Multiply the other diagonal, 51 times 6. That's 50 times 6 is 300, 300 plus 6, 306. And so we're still asking the question, are those equal? Well, absolutely. So yes, these ratios are in proportion. Yes, they are proportional. Yes, they form a proportion. Yes, they are equal to each other. This method of cross-multiplying says if it starts off being equal and you cross-multiply it, it's going to stay equal. So we'll multiply here. And if you've got a calculator to speed up the number crunching, you can do this stuff even more quickly. 12 times 50, 600. 20 times 32. And so we're asking, are those equal? Of course not. So no, these are not proportional. Cross-multiplying allows us to check if they are the same very, very rapidly. Before we had cross-multiplying, if we wanted to know if the ratios were the same, we essentially just divided them out and turned them into decimals. Okay? Before, we were using division to check if they're equal. Now we're using multiplication to check if they're equal. Just building our skills, building our toolbox. Like yesterday, we know that we can cross-multiply to create equations. 18 times t and 42 times 3, that equals 126. When we divide by 18 to solve it, we know that we obtain t equals, and that gives us 7. Done. Once again, we'll remember, it doesn't matter where in the 4 positions the variable lies. We'll still multiply 10 times p, and the other diagonal, 16 times 45. So that gives us 720. And when we divide by p, sorry, not divide by p, but we divide by our coefficient 10, 720 divided by 10 gives us 72. We're done. Last example that we've got for the day. Actual example, after the games last night, I had to run over to Family Dollar and buy some top because it was on sale. Gotta save some money, right? Yeah. Alright, so over at Family Dollar, they were selling cases of Mountain Dew, 3 cases for $10.
Oh, you're selling.
I had $70 cash with me. How many cases could I actually buy? Well, when we're looking at this, we're saying it's $10 for 3 cases. Remember, anytime you're setting up a proportion, the labels tell you exactly where you need to do it. Everything is built around making sure that we've got matching units, $10 and cases. Well, I had $70, and so I'm looking for how many cases. Build our proportion, we can cross multiply and solve. So 10x, 3 times 7, 3 times 70 gives us 210. Dividing out by 10 says 21 cases. I was able to buy 21 cases of coffee.
That's a lot of coffee.
And that's it, we're done. We've seen getting more practice on building proportions, on cross multiplying, and the only so-called new piece is that we can use cross multiplying to verify, are these things proportional, yes or no?